All right, folks, today we're going to look at parallelograms. We're going to talk about what makes parallelogram parallelogram. We're going to spend a day on each of the different quadrilaterals. Today's parallelograms, tomorrow will be rectangles and rhombi and so forth. What will happen each time is we're going to give you two shapes at the top. This one we're going to talk about the outside of the shape, and this one we're going to talk about what happens with the diagonals of the shape. Okay, and then we got some examples of questions that could be asked once you know these two things. So first things first, we know that on a parallelogram there are two sets, and my pen is not going to write. Wonderful. Let's see if I got another one. We've got two sets of parallel sides. So I'm going to mark that. Two sets of parallel sides. That one and that one. That's one set. And here's the other set. Okay. The next thing we know is that we have two sets of congruent sides. This side is the same length as this side, and this side is the same length as this side. All right. Here's something else. We have this angle has to be the same as this angle, and this angle has to always be the same as this angle. And there's one more thing that always happens with a parallelogram. To do this, I'm afraid we're going to have to take some notes. I didn't really leave myself much room. You know what? I'll do it in the middle of it. Do this for me. Number 1, 2, 3, and 4. Okay, you ready? Consecutive angles like 1 and 2, or 2 and 3, and 3 and 4, and 4 and 1 are supplementary. That means they equal 180. And so we can say that angle 1 plus angle 2 equals 180. Angle 2 plus angle 3 equals 180. Angle 3 and angle 4, equals 180. And angle 4 and angle 1 equal 180. Any two consecutive angles, these two, will add up to be 180. And that's it for the outside of this. Over here, we got to talk about the diagonals. So we need to draw our diagonals to the best of your ability. If you would like to use a straight edge, I do encourage it. I, however, am living dangerously today. All right, so here's what we know about the diagonals. We know that this diagonal cuts this diagonal in half. This section here is the same as this section here. And we know this diagonal cuts this diagonal in half. So this section here is the same as this section here. The other thing we have with these diagonals is we have a bunch of alternate interior angles. Okay, so we have a lot of angles here that are the same. Okay, in fact, there's 4 different sets. To mark them, I'm going to use dots. Okay, so this angle has to be the same as this angle. Has to be. And this angle has to be the same as this angle. And this angle has to be the same as this angle. And this angle has to be the same as this angle. Okay, so if you're working a problem and it talks about this angle and that angle, they're equal to each other. Or this angle and that angle, they're equal to each other. Okay, so that is it for what properties you need to know about these. Let's take a look at our first problem here. No pictures were given. We're expecting you all to draw the pictures. I'm going to show you how to do it. It's not hard. So LMNO is a parallelogram. So I'm going to draw that. LMNO. So you draw yourself a parallelogram, and it doesn't matter where you start. Okay? But you need to pick a corner and pick where you're going to put L. I don't know where it's going to go. I'm going to put it here. Just because. No real reason. All right? The thing is, M has to either go here or here, and then you have to continue on. So LMNO or LMNO. It doesn't matter, but you got to pick one and go that direction. So I'm going to say LMNO. If you did yours different, as long as you can do it in a circle around it, LMNO, you're fine. So L to M is 2x minus 9. M to N is 5x. N to O is x minus 2, and we are asked to figure out what LO is. Well, I know that LO, this side, is the same as this side. See, 2 dashes, 2 dashes. Okay, but all I know about this side is 5x. Well, if we ignore that for a second, this side has to be the same as this side. Because, again, 1 dash and 1 dash, these two sides are the same. So I can figure out what x is here, plug it in here, and find out my answer. So if I make those two things equal, x minus 2 equals 2x minus 9. Okay, the first thing I would do to both sides is I would add 9. I would go plus 9 to both sides, and that would get rid of that minus 9 and turn that into x plus 7 equals 2x. And then I would subtract an x on both sides. So I get 7 equals x. So x is 7. That is not our answer. Okay? We now have to take this and plug it in here. 5 times 7 is 35. This segment right here is 35. That is the answer that we are looking for. A lot of times you're going to have to take the information you find when you find x and plug it in somewhere. All right, so our next one says that RSTV is a parallelogram. So again, let's draw RSTV. And it says that the diagonals intersect at Q. So I gotta have my diagonals on here this time. Diagonal and diagonal. It says that RQ is 5x plus 1. Oh, sorry, here's Q. RQ from here to here is 5x plus 1. And QT is 3x plus 15. And we want to find from T all the way to R. So what we're going to have to do is we're going to figure out what x is and then plug it in here and plug it in here and find our answer. So these two parts, according to this picture right up here, those two parts, this one and this one, sorry, you can't see that, can you? These two parts I have marked as being the same thing. That means they're equal. 5x plus 1 equals 3x plus 15. So I would first of all subtract 3x. So this side will be 2x plus 1. And this side will be 15. Really? Sorry, I just realized what the answer is. Then I would subtract 1 on both sides. So 2x would be 14. And then you divide both sides by 2. And x is, again, going to be 7. But now what I have to do is I have to take that 7 and I have to plug it in there and plug it in here. Okay, so this one would be 5 times 7 plus 1, and then I need to do 3 times 7 plus 15. 5 times 7 is 35, plus 1 is 36. 3 times 7 is 21, plus 15 is 36. Oh, duh, they have to be the same. You know, this is the same as that. So if I add those together, that is how far it is from R to T. This is 36, and this is 36, so the whole thing is 72. All right, taking a look at our next problem here, we have parallelogram GHJK with diagonals intersecting at L. So GHJK, let's say GHJK diagonals intersecting at L. All right, it says angle KGJ. Okay, let's see where that is. From K to G and G to J, that's this angle right here. This angle is 4x. I'll put a 4x by that. Okay. Angle HJL. HJL from H to J and J to L, that would be this angle, is 2x plus 45. I'm going to write it above here. 2x plus 45. What is the value of angle KJGJ? Okay, well, let's figure out what this is first. Now, what we have is we have that angle and that angle. So since we have the diagonals, we should look at this picture here. And if we look at this picture here, you see that this angle and this angle would be the same as this one dot and this one dot. These two things are the same. These were alternate interior angles. And so we just make them the same. It's going to be 4x equals 2x plus 45. Subtract 2x on both sides. 2x would be 45. Divide both sides by 2, and x is going to be, yeah, I know this, 22.5. Actually, it's going to be a decimal. But again, that is not our answer. We have to figure out the measure of angle KGJ. That was this one. KGJ is 4x. So we need to do 4 times 22.5. I want to say that's 86, but I'm going to check my math real quick. 22.5 times 4. What? Really? No. Oh, wait, yeah. No. Yeah, sure is. That would actually be a 90-degree angle. That's crazy, but all right, that works. So, yeah, the answer is going to be 90 on that one. That's nuts. I didn't realize that. Really? I sure hope I didn't mess that up somewhere. I'm pretty sure I didn't. I'm going to check myself real quick. Let me pause this and double check. Okay, I figured out why that looked weird. I had written down earlier a different thing for 2x plus 45, but evidently I did not pay attention when I was putting it in. So this is fine. The answer is 90. It is correct. Let's move on. The last one here, ABCD is a parallelogram. So just draw yourself a parallelogram. And we've got A, B, C, D. It says angle D is 42. What are the measures of the other three angles? Well, there's no diagonals on this one, so we need to look at this picture up here. Okay. Now on this picture, I see that this angle, which is the one we're talking about, is exactly the same as that one. So if that's 42, so is that one. I'm going to go ahead and mark that real quick. That's 42 and that's 42. All right. Now for the other two, these two are exactly the same. But what are they? Well, what we also learned was that angle 4 and angle 1 equal 180. So to figure out what angle 1 is, we have to take angle 4 plus angle 1 is going to equal 180. So 42 plus angle 1 equals 180. So I'll write that down real quick. 42 plus angle 1 equals 180. To solve that, I just subtract 42 on both sides. And so angle 1 would have to be 138. And if this one, excuse me, as I said angle 1, it should actually be angle A. All right, so if angle A is 138, so is this one, 138. So angle A would be 138, B would be 42, and angle C is also 138. All right, guys, I hope that makes sense, and you're going to have some practice on this in class tomorrow. So good luck to you.